Okay, so welcome for coming here to hearing the talk about high performance Hibernate. First of all, a little bit about myself. I work for Red Hat. I'm a developer advocate for the Hibernate object relational mapping framework. That's my blog. There are around 70 articles related to Hibernate, which you can find there. And also my Twitter ID. I quite frequently tweet about Hibernate-related questions on our forum or on Stack Overflow. And very much this talk is based on the second part of my book, which is High Performance Java Persistence, and which is still not ready. I still have to write 3 or 4 more chapters about it. Okay, so why this talk? First of all, this is a real problem in many enterprise applications. According to Application Dynamics, half of the performance bottlenecks problems originate not just in the database, but in the data access layer. And we want to have performance, because the better the performance, the better the search engine optimization. Google is going to rank better our application than other sites. Also, having mobile clients, it's so much better for our pages to render as fast as possible. Okay, so when I'm talking about high performance, and we need to understand that response time is the most important metric, and from a transactional manager point of view, the response time is built out of several subsegments. For example, we have the connection acquisition time, we have the data access logic, which process or generates statements for us. Then we have the time it takes to send those statements to the database. The database has to execute them. And then we need to fetch the result set back into the application layer. And in the end, there is a little bit of time which we might process the result set prior to releasing the database connection. So this talk is going to focus on this, and will show you how you can optimize parts of the overall response time. Okay, so for this time, I'm going to talk about connection providers, identifier generators, Hibernate relationships, batching, fetching, and in the end, about caching. Hibernate comes with many connection providers. First of all, because it tries to unify the concept offered by JDBC, where we have the physical connection represented by the driver and the driver manager, but also logical connections which are exposed via a data source. So just for testing, the driver manager connection provider is quite okay, because it only uses a rudimentary connection pool. For production, it's quite fine to use 3PO or Hickory connection provider, but the best and the most flexible choice is to use the DataSource proxy connection provider, because as we can see in the following picture, in the following diagram, the data source allows us to just expose an interface to our application. Then we can chain as many data sources as we want. In this case, we are connecting to Postgres, so we're using their data source they provide through their driver. We can also use any connection pool we want, like Hickory CP, which is very, very fast. We can use the data source proxy, which is a very nice framework, which can log all the statements that Hibernate generates along with their parameters. But we can also integrate other custom listeners, like, for example, prevent doing something, or collecting metrics about statements, logging their timings and stuff like that. And FlexiPool is a framework that I wrote to monitor the connection management for a data source, and it also allows you to go beyond the maximum size that's set for a given connection pool. So in this sense, the connection acquisition and the connection release is what what can affect response time for a transaction. And about connection acquisition, Hibernate tries to delay the acquisition as much as possible. For example, if you have the transactional annotation put on a service in Spring, it doesn't mean that a connection is acquired right away. Hibernate just waits until there's the first time it needs to query something, or it needs to generate an insert, update, or delete statement, and that's when a connection is acquired from the connection pool, for instance, from the data source. And that's very good because the shorter we have the transaction, the more transaction we can accommodate in a second, let's say, on a single connection. About connection release, when the connection is released, it's a little bit tricky because Hibernate does something like that. Automatically, when we are using local transaction, the connection is released after the transaction is either committed or rolled back. And when we are using JTA, like that's the case for Java EE, the connection is going to be released after each statement that is executed. And that's not really a very, very good default for every application server, because as we can see in the following graph, when testing and with just 10,000 connections, 10,000 statements that are executed, we can see the difference between the after statement and the after transaction release mode. And of course, there is a penalty that we are going to pay, but 10,000 transactions is not too much. During a day, you can easily run 10 million transactions in a regular enterprise application, and that just adds up. So for many application servers nowadays, it's quite fair to explicitly set the Hibernate connection release to after transaction. That used to be in a way, this aggressive connection release mode, it's because some application servers a lot of years ago didn't work too well when nesting AGBs, and one AGB was opening a connection and the other one was using it. So it was giving a warning that the connection might leak, which was not even the case. Okay, the next thing I'm going to talk is about identifier generators. And as you can see in JP, it's pretty straightforward. You only have auto, identity, sequence, and table. Unfortunately, JP only tells you what, it doesn't tell you how you're going to implement it. And in high performance, implementation details matter a lot. And for instance, the identity generator, which is by default chosen for SQL Server and MySQL, if you are going to use that, Hibernate is going to disable JDBC batch inserts, for instance. And that's because the way it uses the first level cache, because an entity has to be, once you persist it, it doesn't mean that it's going to generate the insert statement, because that only happens during the flush mode. But it needs to know the ID, because when you cache it, the key is composed out of the type and the identifier. And unfortunately, for the identity columns, you have to execute the statement in order to know the ID. So that's why it disables the JDBC batch inserts. Sequence generator, when you're choosing sequence, and if you're choosing auto for Oracle and Postgres, you are going to use the sequence, which is a very good choice. Now, if you are using sequence, you are going to have one round trip to the database to fetch the identifier and another one to do the insert. So in order to optimize this, Hibernate offers several optimizers like high-low, pooled, and pooled low. If you want to use the pooled and pooled low, you'll have to enable this configuration property if you're using Hibernate 4, for instance. But if you're using Hibernate 5, it's enabled by default. And that's the reason when you are migrating to Hibernate 5, you need to be aware of that, because identifier generators might not work from 4 to 5. And between high-low and pooled low, the high-low was a legacy optimizer. It didn't work well with other applications, or when you're trying to insert, you had to know how to the algorithm in order to insert and not generate clashes. But fortunately, the pooled and pooled low are fixing this, so they are interoperable with other systems as well. Okay, so we can see in action the optimizer works. If I'm inserting 50 records and setting the optimizer, the increment size from 1, 5, 10, and 50, we can see that we get a better response time when the sequence increment size is higher. The table generator is not a very good choice because it tries to emulate a sequence, but a sequence is a very optimized object in the database, and the table generator is not, because it's using row level locking, and using locking incurs penalties when it comes to serialization and stuff like that. And you will see in the next slide, how much is going to be that penalty. There are still optimizers for it, but unfortunately it cannot. Even if they optimize, it's still going to be much slower than identity and sequence. Okay, so yes, the optimizers work, but we can see there it's still around a little bit for 50. Even if we go with one database round trip, it's around 0.5 milliseconds, which is quite a lot. Okay, so now let's just compare them. If let's say that I'm in MySQL and I have to compare the identity or choosing the table, even if identity doesn't use JDBC batch inserts, and even if I optimize the table as much as possible, giving it an increment size of 100, and I'm going to insert 100 entities, you can see that it's still the table generator is still worse than identity. And what's even worse, you can see that if the number of threads is higher, the higher the number of threads, the more penalty we are going to pay for it. That's actually the Amdahl's law, what you're seeing there for the table generator, because the contention is going to affect how much you can parallelize it. If we were to compare the sequence and the table, you can see the blue one is the sequence and the red one is the table. Just go for the sequence because it's a much better choice than using a table. Okay, the next thing I'm going to talk about is relationships, which is quite an interesting topic, because it's one thing that you have to know it right from the start, which ones are better than the other ones, because it's much easier to just design from when you're first implementing the application, just choose the right associations. From a database perspective, things are quite simple. You only have 3 table relationships, which are one-to-many, one-to-one, and many-to-many, and they are simply based on foreign keys. But when it comes to JPA and to object-oriented languages, we can have object and bidirectional associations, and we can have, if I have a collection, it can be a list, a set, an index list. So it just explodes the number of possibilities for using, for example, association. And you can see that the most efficient ones are many-to-one, one-to-many when used with mapped by. They generate very good statements. Also, one-to-one used with maps ID is very good because it can use a single database column instead of 2, and that's very good for indexing. If you are going to use bytecode enhancement, even the parent side one-to-one association is going to be fine. As for the many-to-many, if you're using set, it's okay, but the best one is to just map the junction table and use 2 many-to-one to one-to-many relationships. The less efficient ones, you can see them there, they don't generate the most effective SQL queries. Some of them generate, like for example, if you're using an order list, if you're removing from the tail, it's fine. If you're removing from the head, it's going to delete and rearrange or update the statements, and that's not very efficient. And the least efficient one, of course, are unidirectional bags, one-to-many or many-to-many, and they just, whenever you change something, they just delete all and reinsert everything. So you should probably not use that. Okay, now about JDBC batching. When you're using JDBC, if you're using JDBC, you need to know that it offers an API which differs. If you are going to use batching, you have to use one API. If you are going to use non-batching, you have to use other API. Because when you're using batching, you have to add to the batch, and in the end, you have to execute the batch. So the API differs. Now, if you are not going to write your application right from the start to benefit from batching, and then you're deploying it to production, you are going to see that, for example, the writes are not very fast. You are going to think that, okay, I'm going to change, I'm going to optimize it. But if you're using straight JDBC or plain JDBC, in that case, you'll have to rewrite your data access layer to switch from non-batching to batching. But when you're using Hibernate, That's not the case, because you just need to provide a single configuration parameter, and that works because Hibernate generates the statements for you, and that's one advantage for having this auto generation. You have to seize it, and unfortunately for now this is only a global configuration, but we plan on providing a session level batch size configuration, which is going to give you a more granular way of applying it. Like you can have a default general batch size, and some particular transaction can use, for example, can vary the batch size. That's going to be very good improvement. Okay, so we can see in the following graph, 1 is the default. You don't use batching. You can see when inserting 5,000 records, how much it takes to execute them, because you are going with 5,000 statements to the database, and then simply just increasing the batch size, you are going to lower the response time. Of course, from 10 to 30, you are going to see a good improvement, but afterwards, the improvement is not going to be that noticeable. That goes the same. It's the same for update, and of course, it's the same for delete. So yes, you should optimize. In fact, I find no reason why not to use JDBC batch updates in the first place. It's a good optimization. It's just one configuration away to set it, and even if you set it to 10, and it's going to reduce the number of round trips. From 1 to 10, you see a bigger difference in response times, because, for example, in this case, there's a big difference, because it's one thing to send 5,000 statements and another one to send only 500 statements. So you save 4,500 statements. That's why it performed that well. Okay, that statement alone is not enough if you're using cascading, because if you're using cascading on a parent-child association, you are going to interleave the statements, because you insert one parent, then it will cascade for the children will benefit from batching, and then you process another parent, and then the children. And because of that, you're only going to use batching only on children, because batching, it goes only for one statement. You cannot you cannot have batching for multiple statements in the same time. And unfortunately, it's a very easy way to fix that. You only have to provide these two configurations, and then Hibernate will simply rearrange the statements, and it will execute the parents and the updates either first or last, depending if either if you're inserting or if you're doing updates. For the moment, it's not supported for delete statements, but it might be supported in future, so stay tuned. Another thing you have to be aware of, if you're using, especially if you're using Hibernate 3 or 4, by default, if you're using versioning, like if you're annotating with version, your annotation, and you're using optimistic locking, by default, it's in Hibernate 3 and 4, it disables JDBC batching for those entities, and that was because many years ago the drivers were not so mature, and they couldn't mix batching and returning the proper number of affected keys when using optimistic locking. And nowadays things are better, and that's why it's the default option. It's set to true in Hibernate 5. It's only disabled for these 3 versions of the Oracle dialect, 8, 9, and 10. Fortunately, the latest one, Oracle 12, works better, and it's not going to be the case anymore. Okay, fetching. Fetching is probably the #1 root cause for performance problems in many data, not just Hibernate, many data access problems, because it's very easy to simply fetch too much data, and especially because if you're doing in development, you're going to work with smaller data sets, and it's not going to be, you'll not notice it right away, but then the data sets tend to grow in production. You're going to launch your application, and then if it goes, and if it's successful, you'll have to store more and more data, and then you'll start to notice that some queries which used to be fast are not fast anymore, and not just queries, but even the whole business, some business logic methods. So When it comes to fetching, there are multiple things that we can focus on. One is JDBC Fetch size, the ResultSet size, what type of queries we're going to use. We're going to use DTOs or entity queries, and how many association, or how much we're going to fetch with a query if we're going to use entity queries, of course. So first thing first, about JDBC Fetch size. If you are using Oracle, by default, in the Oracle driver, the default fetch size is only 10. And for example, if you are inserting, if you are selecting 10,000 records, you are going to go with 100 trips to the database. That's not the case for SQL Server because it's using adaptive buffering. And also, that's not the case with MySQL and Postgres because they just fetch the whole result set, which is very good for which actually is very good, which is exactly the way it works in Hibernate. Hibernate tries to fetch the whole result set and output the result as list of entities or a list of DTOs or a list of object arrays. So actually Hibernate consumes the whole result set. So when you're using Hibernate, it makes sense to use the way Postgres and MySQL work, or to increase the fetch size. And you can do that even for Oracle. You can provide the following configuration property, and it will apply for every statement that you are going to execute. And that can also work for queries. So you can set a global configuration, and then you can overwrite it on a query basis using that query hint, which is provided as a JPA hint. In a way, when you think about it, maybe hint is not the best way to name it, because you may think about this is a database query hint, but it's not. It's a JPA provider query hint. Okay, so you can see that it really matters. If you're going to use a fetch size of 1 and you are selecting 10,000 records, you are going to pay a big penalty for it. And then even from 10 to 100, you can see that it's so much faster to just fetch, because of course, if you're using 10, you're going with 1,000 round trips. But if you're using 100, you are going to use 100 round trips. So you save 900 round trips between 10 and 100. So of course, you should use that if you're using Oracle. Otherwise, probably the default for Postgres and MySQL is just fine. Okay, so now it's not just the fetch size that can improve, but it's even more important than the fetch size. You have to think about it. It's the result set size, because if we take the previous example, I was selecting 10,000 records, but to think about it, if I'm going to use an UI, what can I do with 10,000 records? I cannot display them in a table. 10,000 records is too much. I cannot display them in a tree. And even if I have a mobile, just sending so much data to the mobile and just simply discard it is not going to be very effective at all. So, and that also applies to batch processing, because if you're going to use smaller batch sizes, you can. It's so much better because you can have shorter transactions, because it's very good to avoid long-running transactions, which put a lot of pressure on the database engine. So that works not just for front-end application, but also for back-end batch processors. It's a good rule of thumb to always limit your result set and use pagination as much as possible. And that's a very good safety measurement, because if the data grows with size, you will select only a window in that, for example, only a window for the query result that query might fetch. Otherwise, if you don't put limits, you are going to fetch as much data as the query can scan, for instance. What's nice about this JPA and the way that Hibernate implemented it, that this works also for native queries. It's not just a thing related to entity queries. So you can write actually native queries and use this pagination, and underneath Hibernate is going to use the database specific, the driver specific pagination. So for example, if you're using SQL Server, it's going to use stop. If you're using MySQL and Postgres, it's going to use limit. Otherwise, for Oracle, it's going to use a nested queries with row number to limit the result set. And that's very nice, because otherwise you'll have to do it yourself. Okay, so we can see that, for example, if I'm going to select 100,000 post entities and 1 million post comments, versus just limit this whole result set to 100 entries, you can see there's a big difference on the response time. That's why I mentioned that it's very good to limit the result set, because you will see very dramatic performance improvement from this setting. But that doesn't work only for raw set. That also applies to columns as well. And if you're using solely entity queries in your data access layer, you are going to see the following problem. You're going to select the whole. You're going to select all the columns when you're executing the SQL statement, and that's not always necessary, because yes, entity queries are very good, as you will see next, but they are not a universal solution to every data access fetching request that you are going to implement. So for example, if we are going to compare the performance between these two queries, you can see the difference. You can barely see when you're selecting only one column versus selecting all columns, which in this case is just 6 columns, when selecting 100 post details and 1000 post comments. So I like this graph because it tells you that, for example, using a custom projection for reading data is a very good option, and you should actually use it, because it allows you to restrict and select only that much data that you need. And it also allows you it forces you to think how much data you need, and not just, because it's, using this way is much easier to optimize a query rather than hunting down why it fetched that association and why it fetched so much data. And if you're selecting all the columns, you probably don't even know how many columns you're going to select, otherwise if you're just counting them manually. So, DTO projections, when you're selecting just a few columns, you don't have to output them as an object array. You can just put them in a DTO. Hibernate even offers you the possibility of using a ResultSet transformer, so you can even generate trees of DTOs, like when you're using a recursive CT common table expression. You can even build trees of DTOs, which is a very good. It's very useful in many cases. So when you're going to use read-only views, it's very good to use DTO projections. Also, if you combine that with native queries, you can benefit from window function when you're doing analytics, and then you can use it for paginated tables as well, which will render much faster than if you are selecting entities. And entity queries are still useful, but they are more useful when you're going to write data. As a rule of thumb, I always select an entity if I'm going to modify it, if I'm going to enroll that entity into, for example, a web flow. Like if I'm going to have a logical transaction that spans over multiple HTTP requests, I'm going to fetch the entity in one request, then comes the user, in the user think time, he'll decide if he's going to change it or not, and then in the next in the next request, he's going to save it, and then I can benefit from optimistic locking. I can benefit from extended persistent context or detached entities if I'm using that. And using this model with optimistic concurrency control and detached objects, which encapsulate the state as if you saw it when you fetched it, is very good, because you can protect yourself against lost updates across multiple HTTP requests, which not even serializable can protect you against, because that only works for a single transaction. If you're spanning over multiple database transactions, you need an application level concurrency control, like the one provided by Hibernate by default if you're annotating your entities with version annotation. Okay, so now, if you're going to use entity queries, or not only entity queries, even if you're fetching entities directly by ID or by natural ID, you have the possibility, of course, of fetching even the association. In Hibernate 3, prior to JPA, all the association were fetched lazily. But then when the JPA 1.0 standard emerged, they decided back then they decided that lazy is only a hint. Even today it's written in the specification that lazy is a hint and it's not mandatory for a provider to implement it. Although all the providers implement it because otherwise the solution would be would perform very badly. So because of this requirement that they put, they decided that the many-to-one and one-to-one should be fetched always eagerly, and only the one-to-many and many-to-many should be fetched lazily. Unfortunately, this is not a very good default. And as a rule of thumb, you should probably always try to use lazy as a default, because it's so much easy to take a lazy and fetch it eagerly on a query basis, rather than have a eager, which is impossible to make it lazy. Even if you're going to use entity graphs with the fetch load graph directive, or even if you're trying to use other tricks or something like that, you will see that it's impossible to overwrite the way the eager fetch strategy, and that's going to be very difficult to tune, especially when you think about it. If you're using eager, you're going to decide during entity modeling how data is going to be fetched. But that's not a good default, because fetching data is a query time responsibility, because at the query time you have the context of how much info you want to fetch. If you put that, if you do that up front when you're doing modeling, it's like you are going to embed queries into the model, because practically using eager is something like that. It either translates to a join or to a secondary select that's going to be executed. So that's why it's better to defer this decision as much as possible, to have the context of the data that you want to fetch, and use lazy as a default, and override the lazy with eager on a query time. And you can do that with, for example, in JPQL, you have the join fetch directive for that. You can also use entity graphs. You can use fetch profile, which is an annotation provided by Hibernate. You can also use it also with criteria API. And the only thing that you'll have to be aware of is that if you're going to use lazy for everything, you are prone to the lazy initialization exception, which you'll have to treat, which you'll still have to treat during query time. Unfortunately, there are some anti-patterns which try to solve the lazy initialization exception with all sorts of tricks, like the following ones, like the open session in view, which is called a pattern, but it's not, it's an anti-pattern. Because what it does, for example, in a filter, on the web, you're going to create a session. You don't allocate the database connection right away. The connection is going to be allocated in the service layer. Right over there, you're going to use transaction there. You're going to fetch probably just some entities. And then the session is not closed when you're leaving the service layer. It will stay open. And then each particular query that you are going to still execute from your view is going to work in auto-commit mode, but on the same database connection, but will still issue a new transaction for every statement. And for example, in MySQL, if you're using MySQL, you are going to put a lot of pressure on the underlying transaction log, because opening many small transactions is not very good. One optimization would be to use a read-only hint for the database, but that's not the case in many implementations. And the biggest problem is that you are going to defer the connection release up until the whole view is rendered, the whole UI is rendered. So if that takes 1 second to render the view, you are going to hold the whole connection for 1 second. So you are going to, if you're only having 5 connections in the pool and everybody does that, you are going to have a throughput of only 5 transactions per second. So that's why it's an anti-pattern. You don't have to use that. That's just like a band-aid or something like that. You have to treat it at the query time. If you need to fetch like 3 association, you have to do that either when you execute a query with a fetch directive, or you have to initialize it prior to leaving the service layer. Another anti-pattern, I'm not sure if you know about this configuration property offered by Hibernate. If you've never used it, used it, it's good. If you think that it's good to use it, you have to think twice before enabling it. Once you enable this property, Hibernate is going to simply solve all the lazy initialization exception problem, because it's going to fetch the associations in a temporary session. But again, this is not good, because a temporary session is going to allocate a new connection, it's going to execute with a new transaction, so it's going to put, again, pressure both on the connection pool and on the transaction log. Last thing I want to talk to you about, of course, is caching. There are several layers of caching that are used in enterprise applications. The first one that you need to focus on is the shared buffers inside the database engine. Every database has it. You have to tune the database so that it runs queries fast, so that all the indexes are stored in memory. That's a very good cache, because it offers you consistency, because all the databases are ACID, it has to be consistent, and it also gives you performance. The more you move away from the database, it gets harder and harder to maintain consistency. And if you're going to use an application level cache, it's even much more difficult to maintain consistency, because you'll not only have a single source of truth, you're going to have the data split both in the database and in the cache. Hibernate stands in the middle, because it brings you both performance, and also it tries to not undermine consistency, as you'll see in the next slides. So where it fits in this diagram, this is quite typical from an enterprise application. You have one master and master-slave replication with multiple slave nodes. And then the database is in the middle. It's accessed by multiple web nodes, which might be even auto-scaled. You have full-text search, data imports, email senders. So you have multiple services that all of them go to the database and try to fetch data from there. So for example, if you're using if you're optimizing the nodes and you're optimizing the shared buffers, you can span as many slaves as you want, and you will get a good performance. But unfortunately, you still have only one master. So if you try to offload the master a little bit, the second level cache is a very good option, because as you know, there are two things that are very difficult in computer science, like naming things and invalidating caches, and that's a big problem with application level caching. It's very difficult to invalidate caching, and if you're invalidating caches, there's also a problem, because you'll have to refetch the whole aggregate, and that's where the second level cache fits perfectly, because it offers you several. That only applies to Hibernate. Unfortunately, the second level cache, when it comes to this property, is not currently standardized. So this only applies to Hibernate. So there are several layers or several caching concurrency strategies that you can use. The least performant, but yet which offers the best consistency is, of course, the transactional one, because it's using JTA. You'll have to use the JTA transaction manager, of course, and then you're going to update the cache and the database in a single global transaction. So if you're going to roll back, you are going to roll back both the database, the database transaction, and also the entry that you put in the cache. So you will never run read inconsistent values. The read-only cache, the first one, well, yeah, you can use that, but if you have read-only entities, you can just use an application level cache, or you can just cache it in the application level. That's very simple. If entities never change, you can store them anywhere, because you will never run you'll never bump into consistency issues. Then you have the read-write cache. The read-write cache, I can say that is a very good default cache concurrency strategy, because it allows you it gives you consistency. It tries to offer you almost the same consistency as the transactional cache concurrency strategy, but it doesn't use JTA, so you don't pay the penalty for using global transaction, because it uses soft locks on the session factory level. If you're going to roll back, when you're going to commit, it's going to work fine. If you're going to use, if you have a high rate of rollbacks, it's not going to perform very well, because during rollbacks. Of course, it cannot roll back. It always writes to the cache, but it uses some soft lock to override the cache entry and to bypass all the cache requests to the database until that guard expires, which is usually 1 minute. So usually it provides very good performance for the level of consistency that it provides you. This one, the read, write, and transactional are write-through, which means that once I update an entity, it's going to be automatically propagated to the cache. The non-strict read-write, for instance, is a read-through, so it works with invalidation. If I change an entity, it's going to just invalidate the entry from the cache, and the next time I'm going to read that entity, I'm going to hit the database. So from this perspective, you can think of that sometimes read-write can be more efficient than non-strict read-write if you're having a high write. Let's say you have a read-write ratio where you have a consistent amount of writes as well. Also, it's worth noting, you should know that if you're going to use non-strict read-write, it doesn't use locking, so in a way it can provide you better performance, but it's prone to inconsistency. There is a very, very tiny window between the moment that it updates the cache and the moment that it actually commits the transaction, where someone can read an inconsistent view. It's a very tiny window, but it can happen, so you have to be very careful about it. As a rule of thumb, as I said, using read-write is probably a very good default. And as I said before in the following diagram, why it's good in a master-slave replication, because then you don't have to always go to the database when you want to modify entities. You can load some entities from the cache instead of going to the database. So in a way, it's a method of balancing the request between the database and the second-level cache. So yes, it definitely helps in that regard. Of course, the entity cache is not standalone. It also comes along with a collection cache and the query cache. Actually, the collection cache is really useful because you can have aggregates of entities that are always loaded from the cache, and you can even bypass the database entirely for the whole aggregate. Especially for the most frequent, the entity aggregates that you are reading most frequently. What's worth noting is that these two caching options are read-through. There is no possibility for the moment of having a write-through alternative to them. So how they work being read-through, they just invalidate, and the next time you are going to fetch the collection or you are going to use that particular entity query, is going to execute it against the database, and it will put the result back into the cache. So if we're going to take the following example, that's how it looks, an entity aggregate. You have a post entity, which has a board. It has all sorts of social media counters, page views. A post, of course, can have multiple tags, because this is a forum. And a post also can have comments, and user can vote on that comments, but they can also vote on the post itself. So for example, the last post that we add to a forum, assuming this is a very successful forum that we are running, they are going to, for example, they are very good candidates to being cached, because most of the time you are going to see the latest posts that are written to a specific blog or something like that. So when you're using the second level cache provided by Hibernate, you can actually load the whole aggregate from the cache, because you can cache the board, you can cache all the tags, you can cache the comments using collection caching. And what's nice about it is that if I'm going to add a new comment, only the comment region cache is going to be invalidated for this particular entity, and everything else will stay in the cache. If I'm going to implement this using an application level cache like Memcached or Redis or any solution like that, and I store the whole aggregate, and even if I change only only the social media counter, or if I add a new tag, it's most likely that I'm going to need to invalidate the whole aggregate and refetch everything and put back into the cache, which takes more time, and it also puts more pressure to the database, especially to the master node. That's where the second level cache really fits into the picture. Okay, so now we covered almost everything. The one about the idle was covered in the beginning. Now, if you have questions about it, I'll be glad to answer them. Thank you.